students, in the last class we discussed about the Ohm's law. We are introduced about the R, that is a new one, resistance, the SI unit of the ohm. In this today's class we are going to discuss about this R, on which factor actually this resistance of the conductors depends. This R is there, right? On which factor actually it is going to depend? If it is depend, how it is depend? Is that directly depends on that R, or is that inversely depends on that which factor? This one we need to find out here. For that we need to make one experiment. For that the wire and the setup will be the wire, battery, key and the ammeter. First case, what I am going to do, I am going to take one nichrome wire. So between this I am going to mention the current which is flows here. So I will attach the nichrome wire and then I will see the reading on the ammeter. So what is the reading I am going to get? I am going to assume that as a I1. Clear. Next reason what I am going to do. Next case, second case will be I am going to take the same nichrome wire only, but I will increase the length of it. I will increase the length of it, and then again I am going to note it down the ammeter reading here. That is I1 by 2. What happened here? There will be some number what we are going to get here, but I'm just mentioning it as a I1 and I2. You need to understand. For the first case, if we got 10 ampere, and when we increase this length we are going to get 5 ampere. That is a decreased here in the second case. In the third case, what I am going to do, I am just going to increase the size of the wire. The thinness of the wire I am going to increase. At third time the reading what I got is I2 is greater than I1. When I increase the size, the ammeter reading what I am going to get, I am going to take it as a I2. Here see, I2 is greater than I1 in the sense, here for the third case we have the more ammeter reading than the first case. And the next case what I am going to do is, same length, same, everything is same, but the material is copper. Previous for the three cases we took nichrome, but in the fourth case only different material I am going to take, that is the copper. At that time the reading what I am going to observe in the ammeter is I3 is greater than I1. In the sense here we got more than this above. Okay, let's discuss case one by one on which factor actually it is going to depend. See, have a look, I wrote here already. In first and second case, when we observe the first and the second case here, what happens? First we got I1, but in the second case when we increase the length, what happened? 2L, it decreases the current. So what I am going to write? When we increase the current, when we decrease the length, current will increase. When we increase the length, current will decrease. This is what we got. So because of that reason I am going to write I is inversely proportional to the L. I is directly proportional to 1 by L, we can call it as, or I is inversely proportional to the L, we can write. And listen it carefully. In the previous Ohm's law we discussed about when I increases, automatically what happens? R decreases. When R increases, what happened for I? Decreases. So vice versa it is. So I am going to write the same thing here. When I is directly proportional to the 1 by R. So this place and this place both are in the denominator. So I am going to equate it. R is directly proportional to the L. Of course, here also I is there, here also I is there. So in the denominator L and R is there. So I am going to write it as the R is directly proportional to the L. And let's have a look towards the third case. What happened here in third case? When current increases, area increases. So when we increase the area, when we did the size of that bigger, what happened in the case of the current? That is increases. See, I2 is greater than I1. Okay, so what I am going to write? When I is directly proportional to the A. If area increases, current also increases. So I am going to write as a directly proportional here. And then I am going to write in the case of the I am going to write it as a R. Why? Because R is inversely proportional to the 1 by A. Of course, what happened here? When R increases, area will decrease. When area increases, R will decrease. This is the inversely. So I am going to write here this one. And when combine this one and this one, we got R is directly proportional to the L by A. So resistance is directly proportional to the length and the length by area. Clear? So the fourth case, what happened when we changed the wire, nature of the material changes, the electric resistivity changes, of course changes. So listen it carefully. Resistance and resistivity. Resistance in the sense the opposites of the current. Resistivity in the sense the particular material capacity of the opposing it. See, in the first, second, third case we took nichrome. But in the fourth case I took copper. When I took a copper here, what happens? I3 is greater than I1. I3 increases, isn't it? We got more current in when compared for this three cases. Though what happens here, so for the particular material we are going to call it as a resistivity, which we are going to represent it as a rho. This is the rho here. So R is directly proportional, R is equals to rho L by A. When we use it the another material, the resistivity also going to changes here. So in order to mention that resistivity, we are going to mention it as a R is equals to rho L by A. Another one, listen it carefully. This is the rho. If we use it the conductor resistivity of the copper, it is a more high. When we use it the alloy like nichrome and different combination of the two metals, that will be the little bit lesser than this conductor, and the insulator totally there will be a too less. Resistivity, I am saying the capacity of the resistivity, how it is going to use and how it is going to measure. And let's have a look towards the SI unit of resistivity. What is the SI unit of resistivity? I hope you got the clear idea about the resistance and the resistivity. Resistance in the sense opposes current. Resistivity in the sense in which material we are going to use, which metal, whether the iron, whether the copper. See, here they given. This is all the best given for you. Each and every material has their own resistivity here. Not all the same thing. See, silver has 1.60 into the power of minus 8. Copper has 1.62 into the power of minus 8. Tungsten also different. See, resistivity in the sense each and every material has their own different opposing capacity. This is how it shows. And the next one is the SI unit of resistivity we need to know. Resistivity we are going to represent in the rho manner and the ohm meter. This is how the SI unit is. How we are going to get this ohm meter? See, R is equals to rho L by A is the one which we got here, and if I am going to substitute each and everything as the SI unit is R, the resistance SI unit is ohm, I am going to write is equals to as it is, rho as it is, L length, how we are going to measure this length as a m here, and the area meter square we are going to measure area square is cancelled here, so remained is rho is equals to, it will remain like this one rho 1 by m. So when we took rho outside, ohm meter. This is how the SI unit we are going to get here. Clear? So you need to remember that this formula. Resistance is directly proportional to the length and inversely proportional to the A, and when this one will be the constant. Constant in the sense the particular given value will be the same for each and everything. Okay, this is all about the resistance factor on which the resistance of a conductor depends on. Thank you.